Let's solve for the unknown that is found on both sides of the equation. Specifically on the left-hand side, it's under a grouping symbol. So we need to apply these processes. But first, let me copy here the given. You have 2 times the quantity 2x minus 2 is equal to, we have 3x minus 7. So we need to distribute rather this here and here. So we have 2 times x is 2x, 2 times negative 2 is negative 4. On the right hand side, it's still 3x minus 7. Of course, you could divide your original equation by 2 on both sides, so remove that. But you will have here a fractional form of your coefficient, which is, for some, is difficult to process. So let's just stick with this here. Now, notice that the coefficient of x on the right hand side is larger than the left hand side rather. So you might deal here with negatives later on, okay? Because if we're going to continue, of course you could have many processes. So let's just be consistent with what we did before. If we're going to have plus 4 here to make this 0, you will have here plus 4 here as well. So you will have here 2x is equal to, you will have here 3x. This is negative 3. Okay? Then you will be subtracting 3x on both sides to make this 0. So minus 3x. 2x minus 3x is negative x equal to negative 3. But you still have a negative sign here. Hence, you will be dividing this by negative 1 to cancel that. By doing it on the other side, you will have a value of your x, or our unknown, which is equal to positive 3. Now, if you don't like this, you could always opt to do this here. Let me have the other process. Let me copy 2x minus 4 is equal to 3x minus 7. I'm just going to present this here to re-emphasize one important property of equality at the same time, so that you could have options. Instead of removing minus 4 here, I will be removing 2x, okay, so that this would become 0, and now my x will be positive. So you have here negative 4 is equal to 3 minus 2 is 1x, or simply x, minus 7, right? And then I'm going to add here 7 here, add 7 here on the other side. For this to become 0, I have here positive 3 is equal to x, which is just the same as this. By symmetric property, you can interchange both sides of the equation without altering the coefficients and their signs. You will have the same result. Now, these two options, it's up to you which you will be using. But of course, for some who are having some problems with negative signs, this first method might be difficult, but nevertheless, they have the same result. Now, talking about the result, let's not be confident. First, let's try to check this. But when we check, we are going to use the original equation, not the equation after the distributive property. The reason for that is to make sure that if there are some errors on the distributive phase, we will know it, because our checking here will not be satisfied. Okay, so instead of using the second equation, we will be using the original equation. So here comes the checking. 2 times, you have, sorry, let me use a black color here. So you have 2 times 3 minus 2 question mark here. Now, checking is not necessarily required. It depends on your professors, instructors, teachers. But let's just try to master it here. So you have 2, 3 minus 1 is 1. Question mark still, even if it's too obvious. 3 times 3 is 9 minus 7. You will have here 2 equal to, the other side is also 2. This time, we have now satisfied our checking. So the result earlier being x equal to 3, or even this form that is the result of that before the symmetric property, they're both correct values of our unknown. Join us to the next adventure involving the unknown.